Hey everybody, this is Science and Beer, and we are analyzing the 2015 UCI cargo plane. We focused on problem areas such as the spar and landing gear connections, wing loading, as well as a modal analysis of the fuselage and wing spar structure. A simplified model was constructed out of shell elements, which lend themselves to the thin wall structure of the plane. Because of the wingspan, a nonlinear static test was run to handle the displacements at the wingtips. A load of 8 pounds was applied to each wing with a fixed roller-style fixtures applied to the two I-beams. The test gave a max deflection of 4.12 centimeters and a max stress of 6.06 megapascals, still below the 20 megapascal yield stress. Shown here is a modal analysis of the first 5 modes at 14.3, 14.8, 21, 23, and 57 Hz. These modes would only be an issue with low-frequency oscillations, such as turbulence in flight. However, such perturbations would be short-lived. The motor frequency is near the 200th mode, but would be dampened out by the wing skin and stiffeners not shown in this model. A more complete wing model was used to simulate forces during banked turns. Aerodynamic forces were applied to 1, 2, and 3G turns at max payload capacity. The 2G turn is shown here with a max stress of 4.2 megapascals. The wing does yield during the 3G turn. According to the SN diagram provided, this allows for roughly 1,000 loadings at 2Gs. Because the drop test could only be performed with the solid model, it was greatly simplified to avoid any high taper ratios in the mesh. Mesh controls were applied to areas of high curvature or near connecting thin elements. The plane was dropped from half a meter with a 30-pound payload, causing a maximum bending stress of 45 megapascals in the landing gear. The stress in the connecting balsa beam is washed out due to the high stress in the aluminum, only reaching 0.4 megapascals. Both the landing gear and the connecting beam are below yield stress. Well, that's all we have time for, but please see our report for a more comprehensive analysis as well as additional tests and data. We would also like to take a second to say thanks to Professor Demas for introducing us to the exciting world of finite element analysis.